actually have nothing to do with the size of the circle. Degrees have nothing to do with the size of the circle. Degrees only have to do with the rotations inside. And what is 1 degree? We'll talk about it in our notes at one point. 1 degree, I don't know, it's a tick mark on a protractor. Yeah. What else is 1 degree? 1/360th of a circle. Let's go get circles and cut them into 360s. No, right? Degrees, yes, I know your brains know them. The whole like right angle is 90 degrees and a straight line is 180 degrees, et cetera, et cetera. However, degrees are awkward because it's really hard to describe what they are. It's a tick mark on a protractor. It's 1/360th of a circle. So how would you actually... So we want to talk about radians because radians are important, and actually at the end of section 4.1 there are formulas. Remember in section 3.5, I'm trying to relate what's coming at the end of 4.1. Section 3.5, do you remember how it was like, okay, so you've covered exponentials and logarithms, let's show you a peek, and I know it was an overwhelming peek, but a peek at how they're used in real life, in finance, in economics, in chemistry, a lot of chemistry, in physics just a little bit. Did I already say that one? 3.5 was like, guess what? They're used elsewhere. Hopefully you can do the math if you ever need to. That's 3.5. The end of 4.1 is kind of like that. Just a little bit. The end of 4.1 says, hey, these things called radians, they're actually super necessary, and let's give you a peek as to when. Now, in section 3.5, did I make you memorize pH levels? Or sound decibels intensities? Or radioactive decay with different isotopes? No. I did make you memorize the PERT formula because it's kind of helpful in lots of different ways, but that's about it, right? People taking the test, the PERT formula, that's kind of important. But coming back. Same thing with section 4.1. I'm going to have you practice the very end of it, showing how radians are useful and necessary. But you're not going to necessarily need to memorize it for the test, and if you do, I'll be very specific to, okay, maybe this formula will show up, but the rest won't. Sound good? But before we get to the application, don't we kind of have to get to what's a radian? A degree. 1/360th of a circle. 1 tick mark on a protractor. A radian. Ugh. Okay. First of all, before we get to radians, basics. Basics. An angle is a rotation. Huh? Does that make sense? An angle is a rotation. Label it theta. Remember Greek letters? Ooh, remember. Sorry, you haven't done this yet. Theta is a Greek letter. And we could use A's and B's and C's, but we use those for sides of a right triangle. We don't want to use those for angles. We could use capital letters like geometry did, but that's just kind of awkward too. So we're going to use Greek letters for the most part. Doesn't mean that an X or a T can't still stand and won't still stand for an angle from time to time. But theta, assuming theta is a positive, so theta is greater than 0, a positive angle is going to measure counterclockwise, opposite the second hand on a clock. And a negative angle is going to measure counterclockwise, the opposite direction. Standard position of an angle, and we're talking mathematically about an angle. Now, if you guys had a protractor, you'd go up to anything and be like, I'm going to make the 0 start here. 45 degrees. We're just talking about if you're mathematically modeling an angle. You almost always have 0 degrees, which is also 0 radians. Start on the positive angle measures up, negative angle measures down. None of this should be new. The vertex of is going to be the origin. If we're modeling it, if we're taking it and writing it on a graph, the vertex, unless otherwise stated. Hopefully you know where this name comes from. Beginning side, initial side. Hopefully that makes sense. The beginning side or initial side of an angle is the positive x-axis. And then what we name ending side. Anybody want to make a guess? If initial is the beginning, ending be? Good idea. Keep going. What would that? Yeah, because the angle is terminating there. You can think of it that way. Terminator, but we won't go into movie quotes. Although, not if you guys have even seen Terminator. Nod your head if you've seen The Terminator. A few of you still watch old movies. Well, it's not that old, but I mean, look at today. People watch what's in Netflix, what's in Redbox, or TV shows. Or wait, no shows whatsoever and just go on YouTube and watch who knows what. Anyway, coming back. Just saying our attention spans are getting shorter and shorter and shorter. Anyway, it's weird. Standard position. So what do we know? The vertex is at the origin. The vertex is at the origin. Initial side is on, I'm just putting words to what I already said, the positive x-axis. And if theta is greater than 0, you're measuring counterclockwise. And if theta is less than 0, then we're going clockwise. Those are basic characteristics to any angle in what we would call standard position. Once again, you can take a protractor to anything and start measuring the angle without even thinking about really an x and a y. You need to think about the little measurements on the protractor, but you could put that anywhere you want it to be, and that's something in physics as far as we're not bound to the xy always being like this. We could actually rotate it somewhere else. But for right now, standard position on our paper, those are the key characteristics. Now, at the very bottom, I introduced Greek letters. Theta is one. Does anybody know 2 other ones that are mentioned in the Bible? Omega. What's the meaning of that name, calling God the Alpha and Omega? What is Alpha and Omega? The first and last letters of the alphabet. What alphabet? This alphabet. No, but that's true though, right? Like some of these are used in lots of frat or sorority houses as far as like the actual, like if you guys watch Legally Blonde, it's like a lot of the Greek letters are used. That's true. We've seen this one. Isn't that in the table set up for our calculator? Because delta means change in sometimes. In different like sciences, we could talk about like gamma rays, right? So there's a lot of places where the Greek letters are used. Am I going to make you memorize the entire alphabet? Probably should, but no, I won't. I actually am going to highlight one more because one of these actually shows up in homework, and I want you guys to know its name. That one shows up in homework. New does. But anyway, I want you guys to write down the highlighted ones. The uppercase and the lowercase and the actual names. These aren't the only ones that would ever be used. We use alpha, like I use alpha because if I'm talking about multiple angles, I usually go theta first. But if I have multiple ones, I might do like an alpha and beta. That's okay. That's okay. I actually don't even like this drawing of alpha. I don't think it's as accurate. Alpha usually is just a little bit more like a shoop, but kind of a fish. Kind of a Jesus fish. Yes, like the ichthus. The ichthus, yeah. Well, it should be a little bit. No, it comes to a point, though. You guys know what I mean? Yes, it does. It comes to a point. There you go. There you go. That's a good one. It comes to a point. Then you have like the hardcore evolutionists that are like having whatever, eating the fish, and you're like, okay, you're cool. Go team.
Is that an S for delta?
S for delta? No, it's a D with like a curvy top. It's not an S. It's a D. S would be like this.
That is totally an S.
You can describe it however you want. You could call this an upside down B, but I call it a P. So you call it what you want. It's supposed to be a curvy little D.
Why is signal the lowercase 2 letters? No, we use the capital version.
We use the capital version for series.
Why is it 2 letters?
That's the more common one, but there is another variation. They're just showing the other variation. Yeah, The capital is just a little bit,
Like, she's gonna.
yeah. I think the lowercase theta is usually smaller. I don't know why they made it the same size. I think it's usually a little bit smaller, but that's okay. Yeah, for like the sororities and stuff, you see the capital letters, right? Like this one, you probably see omega a lot. Alpha, beta, gamma, delta, epsilon. Zeta, eta, theta, iota, kappa, lambda. Tried to teach me the Greek alphabet. I had fun for about seconds and then just kidding. See me. I was like getting the names down, but he was driving, so doing like the pictures or the letters, but huh? He knows it. He like reads the Bible in Greek and Hebrew. He likes Greek better. It's easier. I have to look at his Bibles and be like, whoa, but I have no idea. It's cool. You guys got him? When are we going to actually use them? Well, you know how 4.1, the N kind of applies? You might see a couple of these in those application-y problems. If you see them in chemistry, I want you to actually know the name of them. But a lot of them are actually named by the letter themselves, like I was saying earlier with the gamma rays. Anyway, you're going to see phi, which is, I don't want you to be confused by. It is not an empty set. You guys know what an empty set is? It is like a, hey, the answer is nothing. You can kind of say undefined is an empty set. It literally means like a set with no answers. That's not this. These are Greek letters, and the Greek letters, they're actual representations. Yeah, they're actual letters. They're not denoting like a numerical value at all. So theta and phi are two totally different things. So if you see like a theta with the sideways and this one that's vertical and going through, I just want you to know it's a Greek letter, no big deal. It's like using an alpha and a beta. It's just an X and a Y. It's a snazzy way of naming angles. Okay? Radians. What are they? Let me give you guys a second. I'm going to zoom in on the pictures. Actually, we don't even need you to really be skipping space or anything like that. So let me just bring this up. And let me zoom in. Can I bring it up a little more? Yeah. I'll give you a second. And as you do that, I'm going to get my little illustration ready to go. An illustration to illustrate. P.S. It was random, but Honors Precalc had one. A flexible ruler. I know it's random. But Honors had one. A flexible ruler. Flex, just curious. You guys know what I'm talking about though, right? Yeah. Like the wiggly ones? The But the nice ones are like the little baby ones. These ones that can fit in like a pencil pouch. And you can just get it out for a straight line.
Can you draw a perfect circle?
No. Mrs. Leon does pretty close. That's all. Let's use this one. You guys almost have it? It's not.
Oh, it's slightly more than
But the circle is a bit more than the 6. 6.28. All right, I need some helpers. Let's use blue. Lauren, I want you to cut me a piece of tape that measures from one side to the other side of the circle going through the center. Yeah, do the best you can. You can have people who check your work. Having it go through the center from one side to the other and try to cut it so it is as precise as possible. It's okay. Salma be available if she needs her hands. She's like, yeah, I got you. It's okay. It's not an easy task. Hey guys, what's the measurement across a circle that I'm trying to have Lauren represent right now? Diameter, right? So what I'm having her do right now is try to get the length from one end to the other end of the circle. That way it's accurate. If the diameter is the whole thing, what would a radius be? So diameter is the whole thing. This is half. So when she gets that piece of tape, there you go. Try to go ahead and trim the tape, yeah, to where it's the exact length or as close as you can show me of the diameter. You can even do it like curved if you want. I want you to think about radians. I want you to think about it as a flexible ruler where the units are radiuses. Ooh. Can I do radiuses? I'm not sure it's a word, but that's okay. Multiple radii? Ooh, radii. I'll do radii. That's much more proper. No radii. Because a radius is singular. Radiuses, I don't think that's proper. I think radii is the plural of radiuses.
I never thought of radian as being derived from what a radius is.
What else would it be derived?
I don't know. I feel like math makes up words all the time.
P.S. That's an angle, right?
Yeah. Yes.
P.S. That's an arc length. Maybe you don't remember that one so much. But S is arc length. R is radius. Now hold on. It's not just any angle, because degrees have absolutely no meaning as far as the size of the circle. So it's not an angle in degrees, it's an angle in radians. But why? What do you think? You got it? Cool. It's pretty good. I like it. I think it's through the center. Now guys, this is the diameter, right? What's that formula built on? Or even what did I put up here? Did I put diameters? No, I put radii. So how am I going to take this piece of tape for this circle? And how am I going to get a radius if this is the diameter? Yeah. No, to cut it in half? She was so precise. Don't do that. Lauren, how can we cut it in half? I would say fold it. No. I don't want to mess up your handiwork, so I'll let you do it. Fold it? No? Yeah, I know. I would be too.
Tape is like the most difficult thing to do.
Right? Okay. I think.
Yeah.
Can you cut? Okay. Okay. Now, can you go ahead and make me a ruler of radiuses, aka with the tape? You're going to have to put a little bit, put it to the edge, and then mark with the expo. Mark with the expo, mark with the expo. Is that cool? Okay. She's making a ruler of radiuses. What radiuses? This radiuses. This object's radius. Now, what would have to change if I change my object? Everything. But the idea would remain the same. But would this tape, if I was to make this bigger or smaller? As soon as I change the size, why? Because radians are built on the size of the circle. Interesting. for radians? No, because it depends on the object and the object's radius. Well, it's radius, and the radius, like if I put them all together, is going to be a ruler of radii, right? Okay, here's what I want you to do. Joe, can you just put a tape all the way around and try to cut to where it's the circumference? Does that make sense? Chris, be extra hands if he needs it. Okay, so as they're doing that, I want you guys to think of flexible ruler, right? Measuring around. A measuring tape, is that a good way of thinking of a flexible ruler? No, because measuring tapes are awkward. Have you guys ever tried to use a measuring tape to go around it? Like, but do any of your moms, or I should say people in your life, to not stereotype, whatever. So, have you ever been around people that sew? Or have you ever had to go be measured for like a tux for a wedding, or like for a dress for a prom, or you've needed it to be like hemmed or altered? What do seamstresses have? Yeah, have you ever watched America's Top Models? They have measuring tapes, right? Okay, they have measuring tapes. That's maybe the best way of talking about a flexible ruler is a measuring tape, because a measuring tape is a ribbon, and a ribbon can easily go around. I mean, that's why we can get our measurements for some piece of clothing, et cetera, et cetera, et cetera, or for alterations for a piece of clothing. Okay, if you have a measuring tape or a ribbon, or we're using tape because it's to make sure it's like precise, and like Lauren it was easy to put the tape on and then mark it. She has a ruler of, how many radians did we get on there, kiddo? 6 and a little bit. That might be very, very, very helpful. Why am I saying very, very helpful? Check out this circle of a different size than that circle. I'll hold it up in a second. How many of its radiuses seem to go around? 6 and a little bit. Interesting. How many go around a half circle? 3 and a little bit less than that little bit, right? Interesting. Okay. That's all right. So then unwind it and then put it on the ruler and then measure with the radian, or by the radians, the radiuses that Lauren marked. So why aren't radians called radiuses? Well, that's just awkward. Who wants to call it radiuses? So radians are a lot nicer. There's probably a better reason than that. But whatever, that's what I use. Radians are radiuses. Radii around a circle. But I want the radians to stick that they're radiuses. I know it's a struggle, even though I don't like the word radius, but that's okay. As they tape it. Guess what? It's past 1. It's past 2. It's past 3 and 4 and 5, and he's trying. And then I think Chris and Joe, was it a little bit short, a little bit shy of the actual? Okay. So they're gonna imagine going a little bit higher. And as they're imagining going a little bit higher, why did I have them go all the way around? Why didn't I just have them go halfway around? How complicated would that have been? Where's halfway? I mean, if you kind of like drew lines, perpendicular lines, maybe you could measure the halfway point. But otherwise, it's easier to go all the way around a circle. Guess where pi came from? Pi came from a lot of people figuring out in many different cultures in many different places, because they couldn't communicate way back when, aka like thousands of years BC. Many different cultures figured out the measurement around a circle has some sort of special proportion to the measurement across a circle. It was really hard to measure radii. That's like halfway across a circle. That's awkward. But measuring across, all the way across, was easier. And they've figured out that there's a special number that seems to keep on showing up over and over and over and over again. Not just in this application, but in others as well. But they kind of got down to defining pi as being the circumference divided by the diameter. Or another way of looking at it is the circumference all the way around a circle divided by 2r. Which another way of looking at that is 1/2 of c over r.
Isn't it kind of like common knowledge to look at it and know that around is going to be the same as across?
It's not the same, though.
Well, not the same, but it's
The around is 3.1415926, the across. Weird, right? The around is 3.1415926, the across, aka a decimal approximation of pi.
You know, like a lot of pi.
That's about as much as I have. And that's because a few years ago, it was March 14th, 2015 at 9:26 a.m. And then you could do the seconds. Ooh, no kid did that. No, one kid did. 3.1415926. I forget the next two digits. What are the next two? Some of you have it memorized. Where's Abby? Abby Crisola would get it. 3.1415926. Yeah, you can ask Siri. She knows math. She looks up at Wolfram Alpha using her algorithmic whatever. What's after 926? She's going. Do you have it? 53. So it would have had to be 0.53. That would have been so hard to catch, though. Catch. Yeah, I gave him extra credit by taking a snap with the time on it of 9:26 on March 14th of 2015. That was fun. It was awkwardly over a weekend, though, but that's all right. They were all celebrating in many different ways. I was making pies. Pizza pies. Anyway. Huh?
Oh my gosh, I forgot pie day. So much food.
We have until March. Keep thinking of ideas and let me know what the ideas are. But for right now. Oh, got it. We have, if you guys see, we have 1 and 2 and 3 and 4 and 5 and 6 exactly, but when they did it, they were like, oh, when they cut it, because there was a little bit of white space, it was supposed to go a little bit past, because all the way around would be exactly 6.28. I'm going to do ... because that's not the exact, that's the approximate. The exact would be 2 pi. And halfway around, half of the full circumference divided by the radius, the circumference cut into radians. Ooh. The semicircular region would be pi, 3.141592. Question, what's bigger than 1 radian or 1 degree?
1 radian.
Yeah, 1 radian's like a third of a circle. 1 degree is, sorry. 1 radian is a third of a half circle. There's this chick on YouTube. She makes a lot of money by being a recreational mathematician and does different seminars at Harvard and Stanford and all over the place. Her name's Byhart. Super entertaining, if you're a math nerd. But she doesn't like pi. She's like, why didn't they just make a special number tau that stands for 2 pi, which would still be just as cool, and you could say 1 circle is 1 tau. Okay, she can go on her own rampage. I understand it, but it's too late. The construct is set. But, coming back, pi is a half a circle. So this half circular region, this semicircular region, can be cut into 3.141526 radians, aka radiuses, with a flexible ruler measured around. So 1 radian is about 60 degrees. She's alive. Radian is about 60 degrees. What's 1 degree? 1/180th. 1/180th of a semicircle, or 1/360th of a whole circle. What's a radian? It's 1/3 of a half circle, 1/3 of pi, or 1/6-ish of a full circle. Jordan, I said 1/6-ish of a full circle. Yeah.
What was that thing in freshman year you showed us that you took the girl that did the thing on that?
Byhart. It was her.
Byhart.
Byhart, Vihart. She's the one I was talking about. She's a recreational mathematician. Yeah. She sounds like Juno when she talks, though. Okay, radians. When measuring the whole circle, 1 revolution, a half a revolution, a fourth of a revolution. 1 full revolution, 1 full time around a circle, we just saw is going to be 6 and a little bit, as Lauren and Joe and Chris helped us determine, is 6-ish, 6 and a little bit, but more specifically 2 pi. Half a revolution. Well, hold on. Half a revolution is half of a 2 pi is 1 pi. Oh, there you go. Fourth of a revolution, not a half of. We can multiply a half by a half. So a half of 2 pi and a half. Oh. But those aren't the only special measurements of radians around a circle. There are more. We do come back to what Matthew was saying as far as 30, 60, 90s, and 45, 45s as to why we call these ones special ones. Because in geometry, we realize the 30s, 60s, and the 45s have special ratios that we can know exactly, precisely. And so if you guys think about This being 90 degrees, which we should know, 90 degrees in a circle. If this is 90 degrees, it's the exact same thing as pi over 2. 1 full pi is the exact same thing as 180 of those little awkward degree marks. And 2 pi is the exact same thing as 360 of those little awkward degree marks. But there we go. And there they are. So if I was to say, hey, 30 and 60, they're kind of important guys, like in geometry, because of those special ratios that you guys are all kind of like not wanting to remember. That's okay. You don't need to yet. Let's think about radians. Because the main objective, one of my main objectives in Chapter 4 is to think naturally in radians. Maybe not as well as we do in degrees, but maybe even better. Where does 30, what fractional piece of 30 is 30 of 90? 1/3. Good. 30 degrees is 1/3 of 90. Cool. So take 1/3 of pi over 2. What's 1/3 times pi over 2? Oh. How do we get 60s? 2/3. Well, 2/3 time would be pi over 3. Oh. What fractional piece is 45? 1/2. What's 1/2 times pi over 1/2 times pi over 4? But then that starts to get a little bit messy, and you guys are like, oh no, yeah, there's that circle with fractions. It's not really as bad as you might think, because I'm going to have you guys correspond pi to something that's quite amazing, quite spectacular. I might make you all very hungry just in time for nutrition. Because if I corresponded pi to like a pi at, what's still open these days? Marie's Calendars? Marie's Calendars is still open. Or Costco pie. Costco has good pies. Cheesecake Factory, we can go there, but you guys always get partial pieces. Hopefully you don't get a full one. That would be rich. If I said pizza pie, that's one of my favorite pies. If I said pizza pie, that wouldn't work for pi because a pizza is a full circle and pi is only a half, right? So if I think of pizza pie, it's not going to work to correspond to pi. But if I think of calzones, now we're doing all right. Because a calzone is what part of a circle? Ah. Don't worry, nutrition is nutrition is soon. Nutrition is soon. And you'll get something not as good as this, but it's okay. So you can tell your parents, I need to go do math homework and meditate on the meaning of pi. I need calzones. See, you just go and then it'd be great. Do your math homework. But coming back. I want you to correspond pi with a calzone. Okay? Why? Because pi is the representation of the angle measure in radians, or the distance around. We still have like 4 minutes. What are you guys doing? Oh, got it. Tracking. I didn't put 2 and 2 together. First day. I need you guys to think pi is calzone. Okay? If pi is a calzone, aka a half circle, ready? Where would 5 pi over 6 land?
5 pi is like 2 circles.
Nope. Come back. Stop. Okay, 5 pi over 6. It's okay.
It's
Shh. Thank you. Yes, it is. But let's think through it. Because Joe went first to 5 pi. Oh, no, I have to go 5 times, well, 5 half times. No. 5 pi over 6. I want you to think 5 pi over 6. And don't make it 5 pi over 6. Well, okay. Make it 5/6. He has a hurt foot. He gets 5 minutes early. That's the regulation, the school policy. Coming back. Shh. And he left 3 minutes early. 5 pi over 6 can be 5/6 pi. Oh, that's easy. That's right here. Because it's a calzone cut into 6 and I have 5 of them. It's no big deal. Right? Right? So what if I was to do something like, okay, I want you guys to locate for me 7 pi over 4, which would be 7/4 pi. Don't you have more than one calzone? It's a, shh, I don't want to know the degree measure. A calzone's been cut into fourths. But you don't just have 4 pieces. How many do you have? 7. Oh, so you keep going. Yeah, which is why 7 pi over 4 is right there. Because it's 1 3/4 of a calzone. All radians can come back to fractional pieces of a calzone. I mean pi. Or maybe 2 calzones. Because 2 pi. So what are radians? Flexible rulers of radiuses. We still have 2 minutes. You guys are killing me here. Start talking about food and you just all start packing up. Mine too. So, stop. Radians. What do I want you to think? Radians. What do I want you to think? Flexible rulers of radiuses measuring around a circle. And the actual ruler would change for every single circle, but every single circle marked with its radiuses would be the exact same measurement around as far as where it falls. So radians, flexible rulers of radiuses. 1 radian is about 60-ish degrees because it's 1/3 of a half circle or 1/3 of pi. And we're going to work way more on those fractional pieces of pi to get your brains thinking so that you can jump to the proper place in the unit circle. Ooh, that's coming. In 1 or 2 or 3 or 4 in radians, maybe even quicker than you did in degrees. Maybe even quicker. Because if I said, hey, where's 235? You know what's in the 3rd quadrant? Yes, Joe, thank you. But some of you, it might be easier to think of 5 pi over 4. Oh, it's 1 in the 4th. Psh, easy. Got it. Hopefully radians become easier than degrees. But before we get out of section 4.1, which is why this homework isn't, I didn't even write it up, sorry. Due Monday. Thursday. It's not due tomorrow. It's due the next time we meet. There are some things that we need to talk about to finish off this section, like what happens if I was to give you something like 9 pi over 4? Why is that awkward and why is that weird?
It's past like a circle.
Oh, it's more than 2 calzones, right? Because you have 4 slices, another 4 slices, and another one. Okay, so yeah, you do have 2 and a 4th, but it lands right back on. Every time you go multiples of 2 pi, whether you go like 9 pi over 4, which is 2 and a 4th, or whether you were to go 4 and a 4th, you're going to land on the exact same as the beginning. So we're going to have to talk about how to find these coterminal angles, because ultimately when I give you something in a couple sections like sine of 17 pi over 3, and you're like, you're going to have to measure it back to what its location would be to then match it with the sign. All right, cool kids, get out of here. You have an understanding of at least some